This is a video walkthrough for practice 6F. In number 1, we're asked to explain why I squared is equal to -1. I is defined as the square root of -1, so that I times itself gives -1. That's the definition, basically, what a square root is. We're finding the number that multiplied by itself gives us the number under the radical. So, using that same logic, I times I is the same as I squared, so I squared is equal to -1. In number 2, we're asked to explain how square root of 4, square root of 2, and square root of -9 are all different types of numbers. There are simplified forms that are going to look a little different for each of them. On the surface, they all look like square roots, but the square root of 4 is equal to 2, which is an integer, and that is also a whole number. It is a natural number, so it fits into all of those categories, and it's also a rational number. And a rational number is a number that can be expressed in fraction form with numerator and denominator that are integers. So this can be expressed in the form 2 over 1. The square root of 2 does not simplify. And it is an irrational number. And what that means is it cannot be expressed in the form of a fraction with a numerator and denominator that are integers. It has a decimal value which is around 1.414, but that's rounded off. It's a decimal that, in fact, never terminates and never repeats, so it's an irrational number. The square root of -9 equals 3 times I, which is an imaginary number. Okay, in 3 through 22, we're asked to perform indicated operations and completely simplify and write in numbers in terms of I and express answers in A plus BI form. So, in number 3, the square root of -24 can be re-expressed as the square root of 4 times the square root of -1 times the square root of 6. We do this because 4 is a perfect square, that's 2, and the square root of -1 is expressed as I, and the square root of 6 is the leftover factor, so 2 times I times the square root of 6. In number 4, we're going to work on the radical first. The square root of -36 is the square root of 36, that's a perfect square, times the square root of -1, and the square root of 36 is 6, and the square root of -1 is I, so that's -6I. In 5, we have 8 times the square root of -63, so I'm going to bring down that 8. I'm going to pull out a perfect square of 9, and a square root of -1, and that will leave us with a square root of 7, so that's 8 times 3 times I times the square root of 7, or 24I times the square root of 7. In 6, we have negative square root of 54. Notice there's no negative under the radical. What this means is this is going to be a pure real number. 9 is a perfect square that divides evenly into 54. 9 times 6 is 54. So this is -3 times the square root of 6. When we have two imaginary numbers to multiply together, and the square root of any negative number is an imaginary number, we must change them to imaginary number form before multiplying, because that property that you may multiply together the radicands is only valid when only one or both of the radicands are positive. So this is I times the square root of 7 times I times the square root of 3. And when we multiply those together, we get I squared times the square root of 21. And remember that I squared is negative 1, so this is negative 1 times the square root of 21, which is negative square root of 21. Similarly, in 8, we can re-express these as I times the square root of 6 and I times the square root of 10. When we multiply together, we get I squared times the square root of 60, which is negative 1 times the square root of 60, but the square root of 60 has a perfect square factor of 4. So this gives us a final result of negative 2 times the square root of 15, which is a real number, no I in the final result. In number 9, negative square root of 9, that's negative 3, plus the square root of negative 4, that's 2i. So negative 3 times 2i is negative 6i. In number 8, or rather number 10, the square root of 8 is the square root of 4 times the square root of 2. And the square root of negative 6 is, on this one, let's just multiply together first. You can certainly simplify first, but you could also multiply together first. Square root of 8 we can leave alone, and the square root of negative 6 is I times the square root of 6. So we're going to get I times the square root of 48. And then 48 has a perfect square factor of 16, so that's 4 times I times the square root of 33. We could also simplify first, but either way is fine. In number 11, 7i times negative 9i is negative 63 times I squared, and then the I squared is equal to negative 1, so that gives us negative 63 times negative 1, which is positive 63. In number 12, we're adding two complex numbers together. When we add them, we add the real parts together. 2 plus 6 is 8. And then we add the imaginary parts together. 4i plus negative 5i is negative 1i, which is just negative I. In number 13, we can use the distributive property here. Negative 3i times negative 1 is positive 3i. And negative 3i times 9i is negative 27i squared. And I squared is equal to negative 1, and multiplying negative 27 times negative 1 is positive 27. The real number comes first in a plus bi form, and then plus 3i. In 14, we are subtracting, and when we're subtracting a single term, all we really need to do is combine like terms. So 5 minus 6i minus 4i is 5 minus 10i. In number 15, we are multiplying complex numbers, so we can use the FOIL method to do that. 4 times 5 is 20, and 4 times 2i is 8i. 5 times I is 5i, and I times 2i is 2i squared. Combining the 8i and the 5i together gives us 13i. And 2i squared is 2 times negative 1, so that's negative 2. Combining like terms, 18 plus 13i. In number 16, we're multiplying again, so the FOIL method is appropriate. 6 times 3 is 18. 6 times I is 6i. Negative 2i times 3 is negative 6i. And negative 2i times I is negative 2i squared. Combining the like terms, 6i and negative 6i add up to 0, and 2i squared is negative 2, so that means adding 2, and that gives us a final result here of a pure real number of 20. In 17, we're squaring a binomial, which means that we are multiplying it by itself. So if it helps, you can write it out as 7 plus 5i times 7 plus 5i, and then use the FOIL method. 7 times 7 is 49. 7 times 5i is 35i. 5i times 7 is also 35i. And 5i times 5i is 25i squared. So that gives us 49 plus 70i. And then 25i squared is 25 times negative 1, which is negative 25. So now adding the real parts together, 49 and negative 25 are 24, so final answer is 24 plus 70i. In number 18, do not use the FOIL method. Why not? This is not multiplication. This is subtraction. If we read, it says 6 minus 3i minus 4 minus 2i. Remember that when we subtract, it is the same thing as adding the opposite. So the opposite of 4 minus 2i is negative 4 plus 2i. Now we can just add the real parts. 6 and negative 4 are 2, and negative 3i plus 2i is negative I. So final answer is 2 minus I. In number 19, we are multiplying, so the FOIL method is appropriate. The square root of 3 times the square root of 3 is the square root of 9, which is 3. And then square root of 3 times negative 2i is negative 2i times the square root of 3. And then 2i times the square root of 3 is positive 2i times the square root of 3. And then the product of the last is negative 4i squared. So what we'll notice here is that these two terms add to 0, and negative 4i squared is the same as positive 4 because I squared is equal to negative 1. That gives us a pure real result of 7. In 20, we're squaring a binomial, which means that we are multiplying that binomial times itself, 4 minus 2i times 4 minus 2i. So the FOIL method is appropriate. 4 times 4 is 16. 4 times negative 2i is negative 8i. Negative 2i times 4 is negative 8i. And negative 2i times negative 2i is positive 4i squared. So 16, and then combining the middle terms together, or the I terms, we get negative 16i. And then 4i squared is equal to negative 4. So now combining the real parts, 12 minus 16i. In 21, the FOIL method is appropriate, but even if you use the FOIL method, we can shortcut a little bit. This is in the form a minus b times a plus b. That's two conjugates multiplied together, so the result will always be the first and the last products only because the inners and outer products will add up to 0. So 3 times 3 is 9, negative 2i times 2i is negative 4i squared. And negative 4i squared is positive 4 since I squared is equal to negative 1. And 9 plus 4 is equal to 13. In number 22, do not use the FOIL method. Why not? We are not multiplying these two complex numbers. We are adding them. In order to add the real parts, 8 plus 2 is 10, and add the imaginary parts, negative 3i plus 3i is 0. So this is a pure real result of just 10. In number 23, we're asked to rationalize denominators, simplify, and express in a plus bi form. Since I represents a square root of negative 1, we must not have that I in our final answer in the denominator. So I'm going to multiply by I over I and distribute that multiplication to the addition in the numerator. So now we have 9i plus 15 times I squared divided by negative 3 times I squared. Now, let's place our real part first in the numerator. 15 times I squared is 15 times negative 1, so that's negative 15. And then plus 9i is, and then our denominator is negative 3 times negative 1, so that's positive 3. And then we can distribute that division to each of the terms and rewrite this in simplified form, negative 5 plus 3i. Number 24 is similar to 23. Multiply by I divided by I and distribute that multiplication, 4i minus 5 times I squared, and then divided by 2 times I squared. Negative 5 times I squared is positive 5, so that's the real part, and then 4i is positive, or the coefficient rather is positive. 2i squared is equal to negative 2. Now we can divide or distribute the division. So 5 divided by negative 2 is negative 5 halves. And then 4 divided by negative 2 is negative 2. So we have negative 5 halves minus 2i. In 25, we have a binomial denominator. In this case, our strategy for rationalizing is to multiply by the conjugate of the denominator in the numerator and the denominator. And I'm going to distribute the multiplication in the numerator, 20 plus 10i, and downstairs, 2 minus I times 2 plus I is 4 minus I squared. Remember that when you multiply conjugates together, you just multiply the first and the last products together. The inners and outer products will add to 0. So we have 20 plus 10i divided by, and since I squared is -1, 4 minus -1 will give us a denominator of 5. So now we have 20 divided by 5 plus 10 divided by 5 times I, which is 4 plus 2i. In 26, we can rationalize by multiplying numerator and denominator by 3 minus I, distributing the multiplication 6 minus 2i, and then downstairs 9 minus I squared. So 6 minus 2i divided by, and since I squared is -1, 9 minus -1 will give us 10. That gives us 6/10 minus 2/10 times I, or 3/5 minus 1/5 times I. In 27, in order to rationalize the denominator, we can multiply numerator and denominator by 3 plus 2i, the conjugate of the denominator. We'll have to FOIL to get the multiplication on the top. 8 times 3 is 24. 8 times 2i is 16i. And negative I times 3 is -3i. And negative I times 2i is -2i squared. Downstairs, when we multiply a minus b times a plus b, the result is a squared, which is 9, minus b squared, which is 4i squared. In the numerator, 24 minus 2i squared is 24 plus 2, which is 26. 69 minus 3i is 13i. And in the denominator, 9 minus 4i squared is 9 plus 4, which is 13. So this is 26/13 plus 13/13i, which simplifies to 2 plus I. In 28, we can multiply by the conjugate of the denominator in both the numerator and denominator. In the numerator, we can FOIL. 2 times 2 is 4, and 2 times -I is -2i. -3i times 2 is -6i, and -3i times -I is +3i squared. In the denominator, the product of the first is 4, and the product of the last is -I squared. And in the numerator, 4 and 3i squared are the real parts. 3i squared is actually equivalent to -3. 4 plus -3 is 1. And then combining the imaginary parts, -2i and -6i are -8i. In the denominator, 4 minus I squared is 4 minus -1, which is 5. So this simplifies to 1/5 plus 8/5 times I when we distribute that division. In 29 through 35, we're expressing each power of an imaginary number in simplest form. I cubed can be re-expressed as I squared times I, and I squared is -1, so -1 times I is just -I. In 30, I to the 8th can be expressed as a power of I squared. It's I squared to the 4th power, which is -1 to the 4th power, and -1 raised to an even exponent is always positive, so that result is +1. In 31, I to the 21st can be written as I squared raised to the 10th power, which gives us I to the 20th power, times one extra factor of I. So -1 to the 10th power is +1, and +1 times I is I. In 32, I to the 34th can be expressed as I squared raised to the 17th power. -1 raised to the 17th power is -1 raised to an odd power, so that would be -1. In 33, I to the -1 is, by definition, I to the 1 divided by I. Multiply the top and the bottom of this fraction by I, and we get I divided by I squared. And that's I divided by -1, which is -I. In 34, I to the -14th power is 1 divided by I to the 14th power. And since 14 is an even exponent, I'm just going to simplify what we've got in the denominator. That's I squared raised to the 7th power. And so I squared is -1. -1 to an odd power is -1. So this gives us a result of -1. In 35, we have I to the -7th power. That's 1 divided by I to the 7th power. I'm going to multiply by I over I so that we get an even exponent in the denominator. And that will give us I divided by I to the 8th power. I to the 8th power is I squared raised to the 4th power. And I squared is -1. -1 raised to the 4th power is 1, so I divided by 1 is I. In 36, 2I raised to the 6th power is 2I times 2I times 2I times 2I times 2I, etc. So that's actually 2 to the 6th power times I to the 6th power. 2 to the 6th power is 64, and I to the 6th power is I squared raised to the 3rd power. I squared is -1, and -1 to the 3rd power is -1, so -1 times 64 is -64. And the last exercise, -3i to the 5th power is -3 raised to the 5th power times I raised to the 5th power. -3 raised to the 5th power is -243, and I raised to the 5th power can be I squared, which gives us I to the 4th, times an extra factor of I. I squared is -1, and -1 squared is +1, so this gives us -243 times I.